All right, I'm going to work out some of the problems to help you for the celeb coming up here. So let's get rolling. So first one, the transformations, you can tell this one here is going to be moved 4 to the right. So we're going to say 4 units right. And then when it has the plus 3 there, that's going to be 3 units up. The domain is normally for the parent function, it's x is greater than or equal to 0, but because we're shifting 4 units to the right, it's now going to be all the x values such that x is greater than or equal to 4. And remember, the other technique to figure out the domain is to take whatever's under the radical and make it greater than or equal to 0 and solve for x. So if I solve this, x is greater than or equal to, we add the 4, so same thing, so x is greater than or equal to 4. The range is normally y is greater than or equal to 0, but because we are shifted up 3 units, it's now going to be y values such that y is greater than or equal to 3. So use this number here as a kind of a starting point for the range. It could be greater than or equal to that number or less than or equal to that number. Depends on if it's reflected, if there's a little negative sign in front. Okay, this one has a few things going on. So this little negative sign right here is going to reflect it. We would say reflected vertically. And then it's got this minus 7 at the end. So that's going to be down 7. And then that is, and then the 0.25. So that's going to be vertically compressed. And that's vertically compressed by a factor of 0.25. So vertically compressed by a factor of 0.25. Run out of room there. And now the domain is really no change in the domain because it's just square root of x. So that's going to be x such that x is greater than or equal to 0, just like it normally is. And the range, again, it's been shifted down 7. So now it's going to have y such that, and it's going to have y, and it's going to have the 7 for sure. And it would normally be greater than or equal to 7, but because it's been reflected vertically, the graph's going to be going down. So we're going to say less than or equal to 7. I mean less than or equal to negative 7. Sorry about that. So this is the right one, sorry. Negative 7. All right, this one, I guess I already have the answer here. So I got, this one is going to be horizontally reflected because of the negative underneath the radical. And then it's got the 3 under there, so that's horizontally compressed. And remember, it's a little backwards whenever the number is bigger than 1 and it's underneath the radical, then it's going to be compressed. And if the number is less than 1 under the radical, then it would be horizontally stretched. And then the domain, you can see I took whatever's underneath the radical and made it greater than or equal to 0. And then solve for x. So what you do is just multiply, both sides by negative 1. And when you multiply both sides by negative 1, that reverses the inequality. Wow, sorry. I actually need to divide by negative 3. Wowie. So I'm going to divide by negative 3. That's going to cancel out. And whenever you divide by a negative, that also reverses the inequality. So it's going to be x is less than or equal to 0. 0 over negative 3 is still 0. All right, so the domain is x is less than or equal to 0, and the range is actually not any different. It doesn't have any plus anything or minus anything after it here. So y is greater than or equal to 0. All right, state the domain and range. So for this one, the domain, we could figure out, it's normally x is greater than or equal to 0, but it's been reflected horizontally. So we can say x such that x is actually less than or equal to 0. Again, you can take whatever's under here and you can make sure that it's greater than or equal to 0. And if you multiply both sides by -1, that would reverse the inequality. So then it would be less than or equal to 0. That's where we get this. All right, and then the range is going to be, of course, utilizing the 4. So we're going to say y is, and this isn't reflected or anything, so it should be greater than or equal to 4. And then as far as the graph goes, a little sketch, you would have, let's see, so you would go 0, so it's just shifted up 4 units, 1, 2, 3, 4, and then it's reflected over the y-axis, or reflected horizontally. So it would be going the other direction. So it'd be going, be going this way. And really, because of the 2, it would probably be going a little bit steeper. So maybe I'll make it go a little bit steeper because it's vertically stretched by a factor of 2. So it would just go a little steeper than normal. All right, let me graph that one really quickly though too, just to be sure. Let's see. So 2 negative x plus 4. Yeah, so pretty decent. All right, next one. Okay, now we're just writing an equation, a possible equation that has these characteristics. So we would say y equals, and it's been horizontally compressed by 4. So that means inside of the parentheses, it needs to have a 4, and then just right in front of that x. And then it's been shifted up 10, so then that would be outside of the radical, and then we just go plus 10. Okay, write a function that has the domain x is greater than or equal to 3. So we know that would mean that it's been shifted 3 units to the right. So we're going to do x minus 3. And then the range has the 4 there, so that means we're going to have to go up to 4, so plus 4. And what's different about it is that instead of it's y is greater than or equal to 4, it says y is less than or equal to 4. So the only way that could happen is if the graph has been vertically reflected. So we have to put a little negative sign out in front to make sure that's correct. Okay, this one has a domain x is less than or equal to 0. So that must mean that it's got a horizontal reflection. So that would have a little negative x there, because normally it's x is greater than or equal to 0. And then the range says that y is greater than or equal to -2. So then we have to make sure we go down to -2. And at least it's greater than or equal to, so that means we're not, vertically reflecting it, so we don't need a negative sign on the outside. All right, so now we get into our properties. So the property here is when they're side by side like that, you're to add the exponents. So use a little something off to the side just to remind you. X squared times x cubed, what we do there is we add the exponents, 2 plus 3, we get 5. And remember, as I always say, whenever you're in doubt, you can always write it out. So x squared, if you were wondering, geez, should I add those? 2 plus 3 is 5. X squared is really just x times x. That's what it means to be x squared. X cubed is x times x times x. And that should be obvious that now we have 5 x's, so that tells you, hey, that's the same thing as we just need to add those exponents, not multiply the exponents. So that means these ones we're going to need to add. So we're going to say x, and we need to get a common denominator. So this one we're going to multiply by 2, top and bottom. So that would give us x to the 2 over 6 plus, and this one's already 5 over 6, so that means this would be x to the 7 over 6. Okay, next one, whenever you have something, an exponent on the outside, everybody has to get that exponent. So we're going to make sure we distribute it to everybody. So x right now only has x to the first power, so it's going to be x to the 1/2 now. Then it's going to be y, and we're going to have to multiply 2 times 1/2. So that gives you y to the first power. So if you need to do that off to the side, go ahead, but it's 2 over 1 times 1 over 2, and so that the 2's cancel out, and so it's just y to the first. On the bottom, that's going to be 16, and that has to be raised to the 1/2, and then it's x raised to the 5/2. That's what it is when you multiply 5 times 1/2. And then y, and negative 3 times 1/2, so that's negative 3 over 2. And again, if you need to do that one off to the side, you can do negative 3 over 1 times 1 over 2, and you can see that that would be negative 3 over 2. So you can do that for each of those. Okay, so now we're going to do a little more simplifying. So anything that's a positive exponent, we're going to kind of leave it where it is, and anything that's a negative exponent, we're going to switch it. So let's go ahead and leave this x to the 1/2 alone. Let's do y to the first. Now this y to the negative 3/2 is not happy down there, so we're going to bring him up. So y to the 3/2, he's positive now if we flip him up to the top. 16 to the 1/2, we can switch that to a radical. So that's really the square root of 16 to the first power, or just square root of 16. And then we still have the x to the 5/2 on the bottom. All right. Next thing we're going to do is we're going to go ahead and combine those y's. So we're going to keep the base, and we're going to add the exponents. So 1 plus 3/2, we're probably going to have to, get a common denominator. So 1 is the same thing as 2/2. So this is going to end up being y to the 2/2, that's the same thing as 1, plus 3/2. So on the top here, this is going to be y to the 5/2. All right. Then what we're going to do with the x's is we're going to, because they're right above each other, we're going to keep the x, and we're going to have to subtract the powers. So 1/2 minus 5/2, that's minus 4/2. So I'll probably do that one off to the side. So if I did x and it was 1/2 minus 4/2, that would be negative. 1/2 minus 5/2 is minus 4/2, or x to the negative 2. So I'm going to put x to the negative 2 there. And when you do that subtraction, it's always on the top. And then the square root of 16, so that's just 4. And then the only thing we're going to do now is just switch anything that's a negative exponent. So we're going to say y to the 5/2, happy where it is. 4 on the bottom is good. And then x squared needs to come down to the bottom to make it a positive exponent. All right, this one we're going to deal with the numerator first. So we're going to keep the base, and we're going to add the exponents. So 2/3 plus 5/3, so that's 7/3. And then the bottom is x to the 2/7. Then we can use the subtraction property. So we can keep the base, and we're going to subtract the powers. So 7/3 minus 2/7. And the only way to combine those is if we have a common denominator. So we're going to go for, since it's 3 and 7 on the bottom, we need to go for a 21, because that's the smallest number that, they both go into. So we're going to multiply this one top and bottom by 7, and we're going to multiply this one top and bottom by 3. All right, so we got x. We're going to multiply those, so that's 49 over 21 minus, and then this is going to be 6 over 21. So this will be x, and it's raised to the 43 over 21. All right, this one looks a little uglier than it really is. So on the numerator, I'm just going to rewrite it just exactly as it is. And then the denominator, since it has a power of a 1/2, we need to make sure everybody gets it that's inside the parentheses. So that'll be 25. We're going to raise that to the 1/2. Then we've got x, and right now it's raised to the -1, so we're going to multiply that by 1/2. So that makes it -1/2. This is going to be y, and when you multiply 4 times 1/2, that gives you 2. So again, you can do that off to the side if you like. All right, anything that has a negative exponent, I'm going to flip. So this has x to the 1/3, so I'm going to leave it. It's positive. Let's see. The 25 to the 1/2, I'm going to make that a radical. So that's the square root of 25, and it's to the first power. That's where the numbers go. The denominator becomes the index, and then the power right there, becomes this power. So you just have to know where the 1 and the 2 go. And then, let's see, what else? So the y to the -1 here, I'm going to bring down to the bottom. And there's already a y squared there, so I'm going to rewrite that. And then now it's going to have a y to the first. Again, this y to the -1 came down. And then this x to the -1/2, he was really unhappy on the bottom, so we're going to bring him up to the top. He'll be happy up there. Okay, so now we're going to keep trying to simplify. So on the bottom, we've got the square root of 25, which is just 5. And then this is 2 plus 1, so that's y cubed. And then we need to figure out what we're going to do with the top here. So we're going to keep the x, and we're going to add those exponents. So we need a common denominator. So let's multiply this by 2. Let's multiply the top and bottom by 2. And then let's multiply this one, top and bottom, by 3. That's what will make it a 6 on the bottom. So this first one will be 2/6, and then plus, and then this will be 3/6. So that means we're going to have x raised to the 5/6. So that would be your final answer. All right, now we're just going to convert from radicals to fractions. So whenever there's not an index, when there's no number here, we have to know that it's a square root button, or square root index, a 2 as the index. So we're going to go 1 over, and we're going to say this is 9 to the... Actually, I'm going to go ahead and just take the square root of 9. So square root of 9 is 3. So I'm going to say 3. And then I'm going to rewrite this. I'm going to say this is the square root of x squared. So I'm going to do it just a tiny bit different. So now I'm going to go ahead and change this radical to a fractional exponent. So this is going to be 3, and then it's x to the 2 over 2. So remember, the index becomes the denominator, and then this power becomes the numerator. So we know that x to the 2 over 2 is really just x to the first power. So the best answer is 1 over 3x. So there's another look at it. You can change the 9 so that it's 9 to the 1/2, x to the 2/2, and then, simplify it a little bit there as well. So I just kind of went a different route, but of course you get the same answer. All right, so this one, we want to change it to a radical. So remember, the number on the bottom is the index, so it's going to be a third root. And then this is x squared, just whatever is in the parentheses there is what goes under the radical. And then it's going to be raised to this power, so it's going to be raised to the 5th. And then we can do a little bit more. We can do cube root, and we can make that x to the 10th power. So then that would be your best answer. Okay, this one, we're going to change it to a radical. And so the index on the bottom is a 3. So we're going to do the cube root of everything in parentheses. So not 24, 27. So 27x to the 4th. So you can do the cube root of 27. That's 3 times, 27 is 3 times 3 times 3. So the cube root of 27 is just 3. And then you still have the cube root of x to the 4th. So that's your best answer right there. And that might be it. So good luck. Yep. And then all these I solved already on that document. So should be in good shape. Let me know if you need anything else.